three different equilateral triangles are drawn outward from triangle ABC, such that each equilateral triangle shares one side with ABC. And as we are going to see, the original triangle ABC is going to have angles of 30, 60, and 90 degrees. So let's draw what's going on. So we have our original triangle with, if I can draw a triangle, 30, 60, 90 degree angles. So let's make this 90, we can make this 60, make this 30, and we're drawing equilateral triangles outward from each side. So we have this first one from this side, we can have our second one from this side, something like this, and the last one from the shortest side. And what are we doing with the triangles? Well, we are connecting the centers of the equilateral triangles, and it can be proven that when you connect the centers of equilateral triangles, we get another equilateral triangle called outer Napoleon triangle. That's fascinating. So let's connect the centers of the triangles. So the center, and the center. And we are going to get, let me use purple for this. We're going to get another equilateral triangle called outer Napoleon triangle. So let's connect the dots. The hardest part about this video, connecting the dots. Now what do we have to do? We know the area of this outer Napoleon triangle is 252. Okay, so we know this area. Is 252. So area of Napoleon triangle is 252, and we wish to find the shortest side of triangle ABC. It can be written in the form a times 3 to the b, and we wish to find a times b. So let's try to do so. Before we go on, I want to recognize Nicholas Patel, who was the very first person to correctly answer last week's challenge with the answer of 5. Let's endeavor to obtain the same answer. So how can we attack this question? Well, to begin with, we have lots of 30 degree angle, we have lots of 60 degree angle from equilateral triangles, and it looks like we have some 90 degree angles as well. So the natural thing to look for is another 30, 60, 90 triangle that we can forcibly generate, or maybe even a right triangle that we can generate inside. And usually, if we can draw lines to relate the side of one of these equilateral triangles with the sides of 30, 60, 90 triangle. So if we can establish a relationship between the sides using some right triangle or 30, 60, 90 triangle or even equilateral triangle, it's going to help us immensely. And in our case, I see one way of drawing lines, and it's like this. Here's a line, because doing this, we already have 30 degrees. We have another 30, because this entire angle of equilateral triangle is 60, so we have half of it. So we have 30, 30, and 30, which makes up 90. So amazingly, we have this right triangle inside. So having noticed this, the problem becomes much simpler. So we wish to find the length of the shortest side. So we want to find the length of the shortest side of this 30, 60, 90 triangle. Let's call that x. Then we know this length, we know this entire length is going to be 2 times x. So we know this entire length. Let me just draw it outside. So in this triangle, we know this is x, we know this is 2x, and we know this is x times square root of 3. And of course, we can find the length of this and the length of this in terms of x by drawing the perpendicular downward from the centers of the equilateral triangles, because then we have another 30, 60, 90 triangles that are forming up. So we have 2 extra 30, 60, 90 triangles to work with, and we know this entire distance is 2x. So we know this distance is x. So we know that's x. That's telling us that this distance is x over square root of 3. X over square root of 3, because this distance is x, you want to divide by square root of 3. That's telling you this side of this right triangle is 2x over square root of 3. Using the same reasoning for this triangle, we know this entire length is x times the square root of 3, so we know this length is half of it, or x times square root of 3 over 2. That's telling us that this length is simply x over 2 divided by square root of 3. So we have x over 2 right here, and the hypotenuse is of course x. And knowing the size of the right triangle right here, now we can find the hypotenuse. And of course, hypotenuse is the side length of the outer Napoleon triangle, which we know area of. So the side of outer Napoleon triangle is going to be square root of 2x over square root of 3 squared, or 4x squared over 3 plus x squared, which is square root of 7x squared over 3, or square root of x squared is simply x, and we have square root of 7 and square root of 3, multiplying by square root of 3 to top and bottom, gets us x times square root of 21 over 3. So we know this is the side length of the outer Napoleon triangle. And we know outer Napoleon triangle is equilateral, and we know the area of it is 252. And we know area of equilateral triangle is side squared times square root of 3 over 4. So it's telling us that this thing is equal to 252. And of course, x times square root of 21 over 3 is s. So squaring that gets us x squared times 21 over 9. And we want to multiply this by square root of 3 over 4. And we are going to get 252, and we simply have to find x to get the shortest side. And of course, we can make some simplifications, 7 and 3. So we have x squared times square root of 3 over 12. And we have 7x squared times square root of 3 over 12 is 252. Dividing both sides by 7 gets us 252 over 7, or 36. And that's telling us that our value of x squared, let's start with x squared, is 36 times 12 over square root of 3. And 12 over square root of 3 is 4 times square root of 3. You can easily get that by multiplying square root of 3 to top and bottom. And then you have 3 at the bottom, and you're going to have 4 remaining up top with the cancellation. So we have x squared is equal to this. So x is square root of 36 times 4 times square root of 3. Square root of 36 is 6. Square root of 4 is 2. And square root of 3 is 3 to the 1/4 power. And we have 12 times 3 to the 1/4. So that's our shortest side. So we know our shortest side can be written as 12 times 3 to the 1/4, but a has to be a positive integer not divisible by 3. So let's make it 4 times 3 times 3 to the 1/4, or 4 times 3 to the 5/4. Just take 3 out of 12. And we have it. Our value of a is 4, our value of b is 5 over 4. So a times b is simply going to be 5.